right, welcome to this video on solving quadratic equations by graphing. And by solving, we're talking about finding the solutions, the x solutions. We already reviewed in our last lesson that a quadratic equation has this standard form, ax squared plus bx plus c, where a cannot be 0 or it would just be linear. The solutions of the equation are the zeros of the related function, so the x-intercepts. The zeros of a quadratic function are the x-intercepts of its graph. Therefore, finding the x-intercepts of one is one way of solving the related equation. We're going to solve without finding any techniques like quadratic formula or without factoring like you did in Algebra 1, but we will be getting to that eventually, very shortly here, and also building on what you learned in Algebra 1. So what are some words that also refer to x-intercepts of a graph? That would be roots, zeros, and solutions. So anytime we use any of these terms in slightly different contexts, they refer to x-intercepts. The standard form of a quadratic equation is y equals ax squared plus bx plus c, and if you're solving it, it's going to be set equal to 0. How many x-intercepts can a quadratic equation have? Well, there are 3 possibilities. One is if it intersects the x-axis twice, then it has 2 x-intercepts or 2 solutions to the equation. If it touches the x-axis just at one point on its vertex, then it has 1 solution. If it does not cross the x-axis at any points, it has 0 solutions. And we are going to be solving for these intercepts by graphing. So we'll be looking at the graph to see what they are. So this says create a table of values after finding the vertex to get the exact x-intercepts. So I guess this one definitely has integer x-intercepts. But you could just go randomly plugging in x values willy-nilly, and you could be doing it forever until you find something. If you start with the vertex, then you know to test a point to the right or to the left, and it will reflect over. So you kind of get 2 points for every one you plug in. So the x-coordinate of the vertex is negative b over 2 times a. B is 1, so it's negative 1 over 2 times 1, a is 1, which is negative 1/2. To get the y value, we do plugging in the x we just got, negative 1/2 squared plus negative 1/2 minus 6. So if I calculate that, I get negative 6.25. So one of my points, my xy points, is going to be the vertex at negative 1/2, negative 6.25. So about right here where I've graphed it. So that means now a good point to plug in would be the first integer to the right of that, which is 0 on the x-axis. 0. Well, if I plug in 0, 0 squared plus 0 minus 6 is just negative 6. And because a parabola is symmetrical about the vertex or the axis of symmetry line, that means whatever point I got at 0 will also be at the x value of negative 1. So we know we have that. So at 0, it's negative 6, but also at negative 1, it's negative 6. All right, not gotten to the x-axis yet, so I'm going to plug in 1. So 1 squared plus 1 minus 6 is 1 plus 1 minus 6, which is 2 minus 6, which is negative 4. So we're moving up. So I go 2, I'm sorry, I put in 1, not 2. So at 1, it's negative 4, which means at negative 2, it's also negative 4. Okay, great. Let's try putting in 2 now. 2 squared plus 2 minus 6. 4 plus 2 minus 6. 4 plus 2 is 6 minus 6 is 0. Oh, so at 2 I got 0. And that's 2.5. So I go 2.5. That means at -3, it's also 0. So we got the 2 x-intercepts just by making a table here. So the exact x-intercepts are right here. Terrific. Now that works great when the x-intercepts are nice integers. Let's talk about what happens when they are not. Often you may not be able to find the exact solutions to quadratic equations by graphing, but you can use the graph to estimate solutions. So we are going to solve this equation by graphing. And if the exact roots cannot be found, we're going to say what integers it lies between. Okay, great. So I'm going to start again with the vertex. So A is 1, B is -2, and C is -2. Negative B over 2 times A is 1. So the y coordinate is 1 squared minus 2 times 1 minus 2. So that's 1 minus 2 minus 2, which is -3. So at 1, -3, we have a vertex of this thing. So there's my vertex. All right. So I'm going to make a table now. And I am going to put some points into the left and right of 1 and -3. I don't know how many I'm going to need yet. So I'll just put this in the middle. It's my x and y. So I guess I'll put in the point, wait a minute, 1 -3. I graphed 1/2 -3. Let's fix that before we get too far. 1 -3, there we go. All right, so I'm going to put in 2. All right, so if I do 2 squared minus 2 times 2 minus 2, that's 4. Oh, I don't like it when I use that pen tool. It makes everything straight lines, even things that I don't want to be straight lines. Okay. 2 squared minus 2 times 2 minus 2. So that's 4 minus 4, which is 0, minus 2, which is -2. So at 2, it's -2. Which means at 0, it's also -2, which we knew that anyway because that's the y-intercept. I'm making it so my x values are sequential because we need that for what we're doing here. All right, getting close. Now I need to put in 3. 3 squared minus 2 times 3 minus 2 is 9 minus 6 minus 2, which is 9 minus 8, which is 1. So at 3, it's 1. Which means at -1, it is also 1. So we can see when we draw our parabola here that our x-intercepts, we don't know the exact values, but they're somewhere between -1 and 0 and between 2 and 3. And I'm going to write that using interval notation. So the roots are located on the following intervals. Those intervals are -1 to 0, inclusive, somewhere in here, and 2 to 3. So that's my answer. Now it says, how can you estimate the x-intercepts of a quadratic equation from a table on a calculator? Well, I kind of have a table right here. And one of the things you can notice is we said the first interval was -1 to 0, -1 to 0 in terms of the x. You always put intervals in terms of x. But you see how there's a sign change right here? That's how you can tell that it's going from being below the x-axis to being above. The other one was between 2 and 3. Between 2 and 3, we have another sign change. So look for sign changes in the Y column or in the range. That would be a more professional way to say it. Look for the sign column in the range. How can you find the exact intercepts of a quadratic equation from the graph on a calculator? Well, I'm going to show you that. So let's go look at a graphing calculator here. All right, so we are going to graph the equation that we just did a minute ago. And I already forgot what it was, so I'm going to take a quick look-see again. X squared minus 2x minus 2. Okay, so we're going to graph that equation. So I'm going to go to the y equals menu and type in x squared minus 2x minus 2. I've got that graphed. If you look at the graph, you can see it right here. You can get a table. You can even set up your table, tell it to start at let's say -10 and go up by ones. Oh, I have to use the negative button. Sorry, not the minus key. Okay. I'm going to say enter, go up by ones. So now I'm going to get a table. We can see our sign change just where we saw it before. If you look at the table, between -1 and 0, you see a sign change. And then between 2 and 3, you see a sign change, just like our table we did our arithmetic by hand. But let's say you want to get the exact coordinates of it. What you can do is you're going to go to calculate. So you have to hit second trace for calculate and tell it you want to calculate a 0. And it says left bound. So you use your left arrow keys to go to the left of the first x-intercept you want to calculate and hit enter. It drops a vertical line in there. Then it says right bound. So I'm going to go to the right of it and hit enter. It drops another vertical line. Then it says guess. I don't know why it says guess, but I'm just going to hit enter again. And then there's our x-intercept, -0.73, comma 0. We can do that again. Tell it I want to calculate a 0. Oops, I did not mean to do that. I don't want it that far to the left. All right, so now I'm going to arrow over to the right because I'm going to calculate the second intercept. Hit enter, go to the right of it, hit enter. So we're looking for it between these two vertical lines. And there it is, 2.730. So you can get the exact intercepts off the calculator. So you go to second calc. I'm just going to type this in. Use the menu, second calc, and use left and right bound to isolate the 0 you want to find. Okay. So we're going to use the table on the calculator to do that. I also just wanted to show you that you can also use that to find the x-intercept or the vertex. If I go to second calc and I tell it I want to calculate a minimum or a maximum, on our graph, this one has a minimum. So I'm going to go down to number 3. It also does a left bound, right bound thing. So I'm going to the left of the vertex. I'm going to hit enter. Going to the right of the vertex, I'm going to hit enter, and then I hit enter again, and it gives me 1, -3, which was the vertex that we already knew, that we already had up here. So I'm just confirming everything we did in that problem. So use the table on the calculator to estimate between which integer values these x-intercepts occur. So I would like for you to try that one now. Oh, by the way, the one we just did, there's our negative 0.73 and our positive 2.73, just like where we said they existed. But we're going to get the exact x-intercepts for x squared minus 3x minus 4 on the calculator. So I'm going to go back to y equals. It's x squared minus 3x minus 4. So I'm going to graph it. There it is. Oh, this one, it's exact numbers. Look at that. I bet it is. We're going to find it anyway. 0, going to the left, going to the right, and there it is, negative 1, 0. And then I'm going to do the second calc for the other one. All right, I'm to the left of it now. I'm going to go to the right of it. And at 4, and then it says 1e to the negative 12th. That's just a little calculating. That's infinitesimally small, might as well be 0. So 4, 0. So in my notes, I can type the answer that I'm going to do a different color here. The x-intercepts are at negative 1, 0 and 4, 0. Okay, so that's that one. I want this to be a different color so it looks like it's not part of the original notes. There we go. Okay. Solve for the x-intercepts to the nearest tenth using the TI-84 calculator. All right, so let me go back and change it now to this new equation, x squared minus 6x plus 4. Okay, graph it. All right, it does have decimal x-intercepts. Second calc, still doing the same thing. I'm already to the left, so I'm just going to go to the right. So I have 0.76 or 0.8 if we round it to the nearest tenth. I forget if it said tenth or hundredth, but that's okay. We'll get it in a minute. Second calc, 0. All right, I'm going to go over and do the other x-intercept now. So I'm going to get past the minimum. All right, now I'm to the left of it. Now I'm to the right of it. 5.24 or 5.2. Okay, so we can go back and type in those answers now to the nearest tenth. They are 0.8. Oh, I'm not going to write it as a coordinate point. Well, I will. 0.8, comma 0 and 5.2, comma 0. So those are the x-intercepts off the calculator. All right, so that is the end of our lesson on using graphs to find x-intercepts. And join us for the next lesson in which we will use factoring to find the x-intercepts.